My name is Kweku Ngissa, and welcome to today's webinar about key 2022 energy code challenges. Is a 200 amp panel enough for electric ready homes? Now, this webinar is the third in a 4-part series that we've been hosting every Wednesday, 10 a.m. The next and last one will be February 8th. As many of you probably remember, last year, Harrison Sloan was on tour, essentially providing information to prepare our clients and different consultants for the now current 2022 energy code updates. After each of those presentations, we would get people coming up to us with comments and questions and concerns. And so we built this webinar series as an opportunity to distill that information to the broader building community. All right. On the whole, we kind of try to look at the building code and try to anticipate future stumbling blocks. We can't do that alone. And it takes all of you coming to us with questions for us to know everything that needs to be addressed. So if your team needs further education about Title 24 or other things that are going on with the code, please, please, please let us know. We're happy to help you out. We're also happy to potentially start have another webinar series or add more to this series. Now, in the questions and comments that would come up after those presentations, one that was repeat itself regularly was, is a 200 amp panel enough for our electric ready homes? So I took that question to our electrical engineer, our lead electrical engineer, Avi, who's also here on this call. And he'll be helping us during the Q&A. But he's helped me put together this presentation here where we can look at, what it's going to take to make sure that we're prepared for the code as our needs increase, right, with the electric ready mandates and everything else that's coming up. So first of all, just kind of rolling back historically and looking at what's been happening with the code. In the previous 3 code cycles from 2013 through 2019, the big push from the Energy Commission was towards zero net energy, right? This was done through a series of different envelope and lighting efficiency improvements, things like improved windows, things like quality installation QII, that became standard. And then in the 2019 code, we really went for that last push to achieving net zero energy by implementing solar photovoltaics and high performance attics as part of the standard design and building practices. Now, one little weird caveat is we did achieve the net zero energy, but this was based on a home that was using gas appliances. Essentially, we designed our PV system so that the PV was sized to offset the electrical load of a home that was using gas appliances. This code cycle, the emphasis of the energy code has shifted, right? And so this code cycle, we're pushing for decarbonization through electrification. What this really looks like is a push to remove any greenhouse gas emitting appliances from our homes and replace them with an electric version. So, this is typically heat pump technology, right? Most of you on this call know that your buildings are going to be using either a heat pump water heater or a heat pump space heater. And in some cases, both, because a lot of local jurisdictions have also banned the installation of gas lines to new residences. For those of you who are still using some type of gas equipment, this code cycle has also mandated electric readiness, which essentially means that even if you're installing that gas appliance, you have to set up the circuitry and set aside space in your panel boxes for an electric version. So that's really why we've ended up asking this question, right? Because regardless of what you're putting into your building, from the perspective of your electrical loads, your home is going to be essentially all electric. So, right, everybody's asking, is what we've been doing still going to be enough? Is that 200 amp panel going to meet all of those demands? And is it going to meet our buyers' expectations around performance currently, and future upgradability. Over the past 70 years, again, we've really seen electric usage and therefore our electric main panels change quite a lot. Right, this picture over here on the left-hand side, it's a 60 amp sub panel box. I was looking for a 60 amp meter main with branch circuits. Nobody's really using those anymore, right? That's become way too small. Even at this point, right, if you're looking for a house that has a 100 amp meter main with branch breakers, that's not going to be something that we've built, in the past few years, right? You can still find homes that have this service, but if you're building a new home now and you talk to your utility provider, a lot of them are going to say, no, we're not going to be able to provide you with 100 amps only because that's too small. So most of us are already right here, right? I think everybody here is probably at the 200 amp meter main with branch boxes. That's our typical service. As we've now had to push towards designing our homes as if they're all electric, some of our homes are going beyond this capacity, right? We've designed projects, Avi has designed projects that are all electric. He's designed projects that required more than that 200 amps could provide. And therefore we had to upgrade to a 400 amp meter main with branch breakers. Now, if you look at these two boxes, honestly, they're going to be fairly similar. They might take up a similar amount of space in your wall. Obviously, the internals are going to be a bit different, and I'll go into the details about the internals of a panel box in the subsequent slides. But, in your wall, it's going to look the same. You might have to do something different with your ground conductors and maybe with your transformers. But overall, this technology is sort of available, right? One thing that we've noticed in doing our projects that needed more than 200 amps is that this is sort of a new emergent space. We've had to do some things in preparing homes for 400 amps that we've had to look essentially at the technology that's available, and it's still emerging. Some meter boxes are being designed by manufacturers that are going to be coming in Q3 that are more code compliant. But at the moment, a lot of what we've had to do is take our designs to our supplying utility to make sure that they're happy with what we're putting together, again, because the market is really trying to catch up right now to this need for a larger breaker box in some of our projects. So let me talk us through some of our panel sizing or how the panel works, and then after that, we'll kind of look through some scenarios to really answer that question about if we need to go up to that bigger box. Now, if you open up your main panel, you're going to find that there's a meter. It's not really shown here, but then there's also going to be your main breaker and your branch breakers. Now, what a breaker essentially is it's a piece of technology that is designed to make sure that all the metal wires and things like that are in your house aren't going to essentially turn into a toaster oven, start glowing red, get really hot, and then potentially set your home on fire. So these branch breakers connect to the wires that are going directly into your house. And then this main breaker connects to something that's called a bus bar. If you were at the presentation last week on the battery ready requirements, you'll remember that one of the requirements was that you had to have a 225 amp rated bus bar. When we talk about that, we're essentially talking about the metal that is behind the hood of this panel. This has been rated to, again, meet 225 amps. This is not the same as your service size, right? Your service size that's provided by the utility is going to either be equal to, or in the case of what providers are able to give us, it's going to be a little bit smaller, right? It's going to be 200 amps. Similarly, the main breaker here, it's designed to make sure that our bus bar, again, doesn't take too much electricity. So our main breaker here is going to be typically 200 amps for a 200 amp service. And, it makes sure that the bus bar isn't going to have more than that supplied to it, again, so it doesn't turn red hot and potentially cause a fire hazard. Now, if we were to look at the individual branch breakers here and look at the sizes and add them all up, what we'd end up finding is that these branch breakers actually add up to something like 300 or maybe even 400 amps, right? Which is obviously bigger than the main breaker. The reason why we're able to do that is because we know that nobody's going to turn on all of the lights in their house, plug in all of their outlets with the maximum load while also running their dryer and their heater and, their dishwasher and everything at the same time. So the electrical code allows us to take all of these loads and essentially apply a sizing factor to it that says, we're only really expecting that you're going to use this type of circuit this much of the time. From those calculations, we get obviously a much smaller number than the sum of all of these branch breakers. And that's what we use as our demand load. And that allows us to say, all right, if that demand load is smaller than our main breaker, then we feel fine saying that, more or less that our branch breaker and our panel size is enough. Now, these sizing factors and the demand load that we get from this calculation is also sort of a starting place. Again, if you've been to the previous webinars, you've heard me talk a lot about buyer expectations and how those have to be very deliberately and intentionally set. We have to look at, what sorts of options we're providing to the home buyer, right, which is going to increase the load on these homes. We also have to look at what we think these home buyers might want to upgrade in their homes in the future in order to make sure that we're sizing our panels correctly. And then, of course, we have to make sure that we've set aside enough capacity for the future electric ready loads that are mandated by this code, right? Again, that's the big reason why we're all having this conversation, is because regardless of what you're installing, you have to be essentially all electric ready. Now, these electric ready measures essentially say that for any major appliance that you'll be supplying with gas, you have to provide a 240 volt circuit of a certain amperage that will allow that equipment to be switched out with its electric counterpart. So, these appliances are your domestic hot water, HVAC, future cooktop, and a future electric dryer. Again, most of you are already selecting either to install a heat pump water heater or a heat pump space heater, which means that instead of setting aside a space and running the circuitry, you're going to actually install the breaker and you're going to actually utilize this space. The other relevant measures that have really come into effect is, again, last week we talked about the bus bar sizing that's mandated by the battery ready requirements. And then, back in, I believe, 2016, there were EV charger ready requirements that, again, required that we set aside a space for those. So, when we put all of that together, again, regardless of what you're installing in your home, if you're using some types of gas appliances, what our loads have to be calculated for and what they have to take into account is looking at your home as if it was an all-electric home. And that is driving up our loads. So, when we look at these homes, is a 200 amp panel going to work? The quick answer is probably, but the more important takeaway here is that you need to make sure that you're talking with your electrical designer early so that they know everything that's going to be going into the home, including the things that are being optioned. And you have to make sure that they have an understanding of your target demographics and what you expect in terms of upgradability in the future. Again, if we weren't electrifying our homes, we might not be having this conversation, but we are. And ultimately, we want to make sure that we're designing something that not only meets these current loads, but 5 or 10 years down the road, if the homeowner does something, within reason, they're not going to have to upgrade their electrical service to meet that. So the first scenario we can look at here is a typical 1 to 2,000 square foot home. This is fairly small. Let's say this home doesn't have any duplicate major appliances. So that means it's only going to have one water heater. It's going to have one washer dryer, one HVAC, etc. In addition, the PV system has been sized to meet the minimum T24 requirements. The load is probably going to be somewhere around 120 to 150 amps, and that's going to fit pretty comfortably within our 200 amp panel. So, I feel pretty confident saying with this typical home, yeah, our 200 amp panel is going to be just fine. Now, let's say this home grows a little bit, right? We're looking at a 2 to 3,000 square foot home. Again, for this scenario, let's say that we're not duplicating any appliances. So it's still just one water heater, one washer dryer, one HVAC system, and PV that's minimally sized. The home's load is going to be a bit bigger, somewhere maybe between 140 and 170 amps, but that should still fit pretty comfortably within our 200 amp panel. Now, if we take the same home and we start throwing stuff in there, right, we carve out 750 square feet for an ADU. That ADU has its own HVAC system. We maybe consider installing a second EV charger in that house. We're going to get a lot closer to that 200 amp capacity, and it might end up making sense that we need to upgrade to 400 amp service. Again, I'm not going to be able to give you a sharp line. I can't tell you exactly where to draw that line, but when you talk with your electrical engineer and you give them the proper design parameters, they're going to be able to help make sure that that the home you're building is one that will satisfy your needs as well as the homeowners. Now, let's look at a little bit bigger of a house. Let's look at something above 3,000 square feet. Again, for this scenario, we're going to say that it doesn't have any major duplicate appliances. So it's still, maybe it's a very efficient home. And so we can get away with one water heater. We can get away with one HVAC system, one washer dryer, etc. And the PV system is still, sized just to meet our T24 compliance requirements. Even with this home, we're going to find that our load is, 160, maybe 190 or more amps. At that point, you're getting kind of close to 200 amps. We're pretty close to the edge, and so I can't, tell you specifically that it's going to work. Again, you're going to have to talk with your electrical designer, but we're getting fairly close. With this home, if your homeowner was to decide a couple years down the road that they want to install another EV charger, for example, you're likely going to find that the panel is now definitely at its capacity, and they might face some issues with being able to meet that load. Also, realistically speaking, with a house of this size, there's a pretty good chance we're going to have some sort of duplicate appliance, right? We might end up having 2 water heaters, or again, there's maybe going to be an ADU that requires its own HVAC system, or even without an ADU, if it's big enough, it might still be necessary that we have 2 HVAC systems. Additionally, if the homeowner decides in the future that they want to install something like a pool or a hot tub, we want to make sure that the panel has enough extra capacity to be able to withstand that. So, once you start adding in those things, it starts becoming very, very likely that you're going to have to upgrade your panel from that 200 amp service up to that 400 amp service. Again, I can't tell you exactly what's going to push you over the edge, but when you're looking at your panel, you want to make sure that you're discussing these things with your electrical designer, right? Is there any duplicate of a major appliance? That's automatically going to add to your load. Is there going to be an ADU that's attached to the design? Because that's going to mean that you're almost definitely going to have some sort of duplicate, such as an HVAC. And additionally, the usage of electricity is going to be, more similar to having a larger or a two households in the same space. Further, there's the things that are out of our control, which is what is the homeowner going to do in the future, right? Do they want to install a second EV charger, a hot tub, etc.? Depending on the product type and your homeowner target demographics, they're going to expect a certain standard of service in terms of what this home can accommodate for upgrades. So yeah, make sure you're considering these things and that you're talking them through with your electrical designer. So these these all electric requirements and the extra load that they're putting on our panels, this is really fairly new. At the moment, as I said before, our 400 amp panels, we're not able to find something that's technically code compliant. And so we've had to, again, talk with our utilities and provide kind of alternate designs that they've been greenlighting. And at the moment, manufacturers are still playing catch up. So, the ones that we've been talking to are saying, it's going to be late in this year that they're going to be able to offer something that, allows us to simply put it in our designs and install it without first talking to our utilities. In addition to having to, or as an alternative, I suppose, to 400 amp service, there are things that are, again, coming down the line. These are all very emergent technologies. I'm not telling any of you to go out and try to spec it or price it. It's probably not going to be something that you're able to do. But it's just things to keep an eye on for the future. Over here, here's a picture of a demand response system. If any of you have been reading into the code, you'll see that the Energy Commission has been trying to push demand response for several years now. It's something that allows the utilities to decrease loads over a broader community in order to make sure that they're able to supply electricity. Further, there are companies that are providing different sorts of modular or smart meters. So this one in the middle here addresses a potential future issue of panels that need more breaker spaces than what we currently have. This one allows a little bit more modularity, and then both of these allow for maybe a smart app that can limit the amount of electricity that certain circuits are drawing in order to keep us down to a lower level of total amp draw in the homes. So that's everything I got here. Thanks for coming to this talk. I want to open it up for questions here. All right. So let me see. First question I have from Jorge. What are you basing this off of? Minimum code requirements? What method? Optional? Yes. However, 22082. It assumes you have nameplates of every item in the home, and it's never the case when designing. Hence, the standard is recommended. Jorge, can you clarify what your question is?
Hey, Quicker, I can speak to this. Yeah, so we're basically doing code minimum in terms of what we're using for load. So basically, like you said, the load is requiring us to, or the code is requiring us to take every appliance at full load, but we are using the standard method. There's for a dwelling, a single family dwelling, there's no optional method really, but there's a demand or diversity factor that we do apply that's allowed per code. So that gives us the ability to have all these electric appliances and be able to be under that 200 amp service.
Thanks, Avi. So, all right, James is asking, you stated at the beginning that net zero was achieved with gas, but now with electric only, does that current PV ready requirement achieve net zero? So this code cycle, we haven't increased the size of our PV panels. So it's essentially being sized more or less the same as it was done before in terms of the minimum T24 requirement. So it's very easy to imagine that some extra environmentally conscious homeowners might want to increase their PV size essentially to do a better job of offsetting their total loads. That answer your question, James? Right. Brian asks, are you seeing an increased need for additional transformers in neighborhoods? Avi, is this one that you can take?
That's going to really be it. I mean, based off the utility designs, it's hard for us to really say, it's going to need more transformers. But I mean, capacity wise, utility takes a demand based off the load that you're providing. And so, if we're still under that 200, so if each home is under 200, it may be the same. But again, it's going to really depend on the utility design and what they say based off the load you're giving them per lot.
And Quaker, this is Abe. And to kind of address that question as well as we if you remember, we had our meeting with the.
I'll send you the whole thing. Yeah, I signed up.
Sorry, go ahead, Abe.
Just wanted to in relation to that question, we had a meeting kind of with PG&E and discuss some of the parameters around what the future looks like relative to that. The answer is to the question is that right now this is all new, right? And so the utility addressing what a community that's for essential. This is all we're only speaking of communities that are all electric ready, that are battery ready. So we're not really seeing the impacts that we may see. It is planning because it says you can imagine the electrical load may be increasing, but at the same time we've incorporated PVs, we've incorporated potentially in the future there'll be battery ready so that there could be some demand response with that. So those are all things that we're going to have to learn together, but we're not going to address them immediately. In this, these are the baby steps that are going to go into that, and as we understand what these communities look like in the future, well, they'll be able to address it at the load level, community level, and things of that sort, and be able to see. But until then, they're going to plan accordingly based on what conditions were before. There's a long answer.
Thanks, Abe. Let me see. Are there any additional questions? So, Joanne asked, you say 400 amps is not available. So 400 amps is available. The question is of boxes, of main meter boxes that meet the code requirement. So currently, there aren't boxes that technically meet the specifics of the electrical code. There are some workarounds that we have come up with and that we've seen other people using. But again, those are something that you need to make sure that your utility approves of. And they know that this is an issue. They know that manufacturers are still in the process of putting together boxes that explicitly meet the electrical code requirements. And so they are happy to work with you to make sure that that you are able to get the service that you need to your home. The main thing is essentially putting two breakers in the same box. That's really the technical issue. Sorry, Andy Cost asks, what are the workarounds that you're utilizing? You got to put two breakers in the box. You're technically supposed to put them in two separate boxes. Avi, can you speak more to this?
Yeah, I mean, so for the new code, I mean, we just basically, if each building, so including single family dwelling, needs to have a single main breaker, and if you don't have that, you're still allowed multiple breakers. So in this case, what we used to use last year was a 400 amp meter or 320 400 amp meter with two 200 amp breakers within it, and then those two breakers are not in separate compartments, which the new code is kind of stating. So if you do have more than one breaker, each breaker needs to be within a separate compartment, which now Square D and other manufacturers are trying to catch up on. And so that's why we're based off our conversations with those manufacturers, they're aiming for Q3 to 4 to get those, approved equipments that comply with code.
Thanks. And then let's see. Jorge, do you just want to speak to your question?
Hi there. No, just a quick comment there. I personally haven't been able to come up with anything under 200 amps using the standard method for our homes, and I am finding that if you're not early with the design, with the utility design, and they think that your underground is going to be 200 amp overall, and later you're specing 225 or 300, they may not be able to hit you up because of that. So I'm just noting that if you're thinking about going above 200 amps, make sure the utility design supports it. If not, you're in for a shock.
Thank you, Jorge. Yes, and that yeah. And let me just kind of quickly go through some, concluding parts, because that segues perfectly into that. Of course, buyer education is critical to setting their expectations for what their electrical system is going to be able to do. But also, because of the electric ready and, some of the local all electric mandates, we're really pushing these box sizes, and you have to coordinate this with your electrical engineer early so that you can address it again from a larger community standpoint as well. And then again, some of the things to consider is your large home sizes, ADU, duplicate appliances, etc., which are going to impact overall your panel size requirements. Last question here from Dave. What are the next sizes of electrical boxes after 200 amps? As far as boxes, well, okay, as far as service, you're looking at a 400 amp, a 320/400 amp service. As far as boxes, Avi, do we do anything between 2 to 400?
No, typically it's 200, 225, and then it goes up to 400, 300 amp boxes. Probably don't exist, and if they do, they're probably, really expensive.
And not compliant at this point.
Yeah.
So yeah.
All right. Well, thank you everybody for joining this week's webinar. Again, if you have any questions or comments or need any assistance, please reach out to myself, reach out to Avi. We'll be more than happy to answer your questions. And then join us next week. I hope y'all are all excited because, we're looking at money and getting y'all money for, again, your all electric designs. There's a lot of money floating out there. It's going to be decreasing every year, so jump on it early.